Hello everyone, welcome to Learn Overflow. In this video, we will discuss another LeetCode problem that is the shortest path in a grid with obstacle elimination. So this is a hard type problem and we'll understand how we can solve this question easily, how we can find a solution to this kind of problems. So before moving on, if you haven't subscribed to this channel, make sure to subscribe to Learn Overflow for regular LeetCode videos like this. So it's given that we are given an m cross an integer matrix grid. So that's a grid matrix, name of the matrix given to us, and where each cell is either 0 or 1. Okay, so each cell is either 0 0 means the cell is empty, or 1 that means there's an obstacle in the cell. Okay, now we can, like, you can move up down left right from and to any empty cell in one step. In one step you can just go up down left and right from and to any empty cell. The cell should be empty, and wherever you are moving, that should be empty. Okay, so you can move this number of steps. Now further, what we need to do, we need to return the minimum number of steps to walk from the upper left corner, that is the 0 0, to lower right corner, that is the m minus 1 n minus 1. So we somehow need to find a path from 0 0 till m minus 1 n minus 1, right? This is like, till this point, if you see, this is like a pretty easy question. You could find it anywhere and it's easily can be done. Okay, like a simple BFS statement which will help us to find which path to go, and ultimately we'll find the shortest path, right? Like we'll count the minimum number of steps. That, so that's the problem is done, because like there's an obstacle. We will like we'll just ignore that obstacle and find a path to our way, and kind of will, using BFS approach, we can ultimately reach our destination. Okay, that's a pretty easy question. Now the question becomes tough further. They make some complication in the question. They say, given that you eliminate at most k obstacles, so there's another variable that comes into place, a k. That's the k given to us, right? So they say that we can eliminate k obstacles. So whatever there is like k number of obstacles, we can eliminate in our path. So now we need to find out, if we need to eliminate k obstacles, so what can be our shortest path that we can reach? Okay, now somewhere we need to remove those obstacles. Okay, so let's understand what was the previous question. Like, previous question was, find the minimum number of steps. Okay, that's easy. So how we can do that? We can do that, like, in order to find the shortest path in such kind of unweighted graph, we can easily use a BFS approach. Okay, yes, a BFS approach. Now, in this problem, there is a variant of our VFS is supposed to be used. Okay, a variant where we have this row column, but we need to add one more parameter, that is the k, where we can, like, which is the number of obstacles we can eliminate when we start from start at the cell row column. Like, usually what our approach is, we just start from here and we keep a track, if we move right, if we move bottom, if we move up, or if we move to the left. Okay, so we keep a track of all the findings, and we'll keep storing what's the minimum. Okay, so we can start from the last corner as well and find towards the end, or we can start from the starting and go towards the bottom to find out what's the minimum number of steps we need to find. Now here comes in another variable or another parameter which we need to take care of, that is k. This k will be helpful for us in, like, this k is something like we're removing this obstacle. Okay, so in order to do that, what will be our approach? I mean, the approach is nowhere going to change for us. Okay, remember that our approach will be same, but we need to consider a new thing. That is, we need to consider, if we are at like, we are moving to a position where there is an obstacle. Okay, if we are moving to a position where there is an obstacle, then we need to consider, what if we remove the obstacle? Like, just another consideration we need to do, what if we remove the obstacle? Previously, in our other case, what we stopped doing, if there's an obstacle, we are just moving back. Okay, we're just not removing it, like, we are just saying that's not a way we can go, we are finding a new way. Fine. And here what we'll do, we'll simply check, like, continuously we'll simply check, what if we have that obstacle and we remove, what if we remove that obstacle? So if we remove that obstacle, remember, the count of k will reduce, like the number of obstacles we can remove further will reduce. Once we remove an obstacle, once we have used once k once, so the k count will remove. So we'll simply keep a count if we can remove an obstacle or not. If we can remove an obstacle, good, we found a way, and we'll ultimately see whether removing that obstacle gives us a lesser time or not removing that. Likewise, if you just look at this example one, okay, so example one it's simple, like we need to reach from 0 0 till n minus or m minus 1, right? So we are starting from over here, so we need to reach somewhere over here, fine. So how we can do that? We can we can go like the normal way without removing any obstacle will be a path like this, right? But what we can do, starting from here, we can remove this obstacle. Okay, we can remove this obstacle. We can simply remove this obstacle, and what we can do, we can pass through that, okay, and reach our destination. Fine. There's a way. So how many obstacles you can remove is like one obstacle. So we can remove one obstacle over here. Then you can, what we can do, we can move towards the end, and then we can go through it. Like we can remove this particular obstacle also. Like there are multiple paths possible, right? So what's the minimum number of steps? Minimum number of steps is anyway 1 2 3 4 5 6, and it's like the sixth number of steps. Like we removed an obstacle, right? So that's what we are doing over here. Okay, so that's what the path we are taking, and that's how we are not we are just finding an answer. Okay, and ultimately they're saying if we cannot do it, we will return -1. So I hope you can understand that the approach to our BFS, like the a breadth first search approach, will be same over here, but in this case, our just the dimension or the parameters is increasing. That is, we are checking for one more parameter. What is that? A k, which is like we can remove an obstacle. So to do that, how we used to do, like earlier, if there was no k, we had a boolean array of row and column. Okay, and that boolean array is like a visited array, whether we have visited this node or not. So we are finding a path, right? So we used to check whether I visited or not. So now here, in this case, a boolean array will improve a bit higher, and we will check whether, like we'll store, like along with that, I mean along with storing whether you visited or not, we need to store in that what's the current value of the k. Like in the boolean array, what's the rnc represent? Rnc represent what's the current node we are at, or the current row column position we are at. So at this, with that, we need to store one more thing, that is the what's the current value of k we have with us. Okay, so thus one increment will be there, that is the boolean array would end up having a 3D array. Okay, like not a 2D array, not a 3D array, but it's not a big deal for us. Okay, it's not something we should be highly worried about, because we are just checking for whether we can remove that k. Like if we remove that particular obstacle, if there's an obstacle, if we remove that obstacle, what's the value we end up having? And if we don't remove that obstacle, then what's the path we end up having? Okay, so that's the thing we can do. So let's quickly go ahead and write this code. I think that will be much helpful for you. So let's quickly go ahead and write this code. And now over here, we have this solution with us. So we took three things. One, the directions array. So directions array would be returning us what? Directions array will be giving us the direction we are supposed to go, like is 0 1 minus 0 minus 1 and 0. So I'll show you how we will using it over here. Once we are here, I'll tell you how we will be using it. So it's just telling us whether we're going to the top, going to the bottom, going to the left, or going to the right. So that's the idea we'll be going ahead with. Fine. Let's see what further we did. Here's the start of the function, and then we just took our we just calculated m and n, right? There's a m cross n grid is there, so we just calculated m and n. Further, here is something tricky. Okay, let's understand this. Here is something, is like we're checking if k is greater than or equal to m plus n minus 2. So m plus n minus 2 is basically, see, m is the number of rows, n is the number of columns. Okay, so and if you do something like m minus 1 and n minus 1, so that's being the 0 to m minus 1 and 0 to n minus 1 is the total like the end point. Okay, if k is greater than equal to our m plus n minus 1, okay, then we return m plus n minus 2. Okay, so why we do that? This is what we call Manhattan distance. Okay, so if we can go by Manhattan distance, let us go. So if you don't know what's the Manhattan distance, so there's a picture coming up on your screen right now. So this diagram you can understand how this Manhattan distance is calculated. So there's this Euclidean big distance that we calculate. Okay, Euclidean distance is like directly diagonal, but this Manhattan distance is like going by each of the like corner only. Fine. So that's the Manhattan distance. So if we can go by Manhattan distance, done. We will be going by Manhattan distance. So that means if k is more than the total path, then go ahead with it. Like we doesn't care if the whole path is blocked. We'll end up having just enough of k with us. Right? We can remove enough of elements and we can go with it. Right. So that's the first thing. Now, further, what we doing? We took a Boolean array, the one I was talking about. See, it is like a 3D array, but don't get like too much confused with it. What? Because we are habituated with using this m and n, and here we have just one additional variable with us, and what we're doing, we're just storing that variable in it. Fine. So what's the idea is, as I said, is like you're simply keeping a note of what's the current k or the current number of obstacles we can remove at this particular position. Okay, so you are just storing the calculations for that, and that calculation is just storing using another dimension of the array. Fine. Further, we took an queue, and in that queue, we took it as an integer array. We'll keep on adding integer arrays to this queue. Okay. Yes, we can do. It's not necessary that you can always add. Like you need to have only those collection frameworks in the collection. No, that's not necessary. You can add a simple arrays also in queues. Okay, it's not necessary that only classes needs to be added. That's not a necessary factor. Fine. So we are adding an array into a queue. Now, what's that? Initially, what we added? We added a we offered into queue that is 00k0. So don't get confused again. So what is the 00k0? So the first zero is like, see, the first 00 is like the row and column. First is row, then is column, then we have this k, the k particularly we have, and then what's the distance or what's the number of steps we are calculating? This is the distance. So this will be our final answer for us. Okay, so this should be the minimum we are finding out. We're trying to find out this particular element to be the minimum. Okay, so we started from 00. This is the total k we have with us, and we are storing that this is the particular value, or this is the particular distance we have traveled so far. So at the starting point, the distance traveled is 0. Now we mark this visited to be true. So what is the visited? We visited 00. Index 00 is visited for us initially, and then how many k are there with us? With us, there's a total of all the keys we have been given to us, right? So all the keys are there. So that's true. We just visited our, so that basically means we just visited our 00 index, like the first starting point, and we have k elements, like k obstacles to be removed. We have this all the k count with us, then we can remove at most k obstacles. Okay, so that's with us. Now here comes the complete BFS approach, nothing else. Simple BFS approach, the one we used to do. So first of all, we checked if a queue is not empty. So queue should not be empty. We are checking for that, and that's how the normal BFS work. Okay. So what we did, we popped and we pulled an queue or something on the queue. So that's like popping an element, right? So we just took out the whatever the element we are in the front. We have in the front. We just take it out. Fine. Now once we have this element, we have this array. So let's break this array into multiple parts. Okay. So that we first of all it helps us in better understanding. At the same time, it helps us to do what we're trying to do. Okay, so there's no point breaking out into multiple variables. You can directly use those variables, but it's better to just break them down so that we don't make any kind of further mistakes. Okay, so let's break them down. So what it is, there's a row. What's the current row? Top 0, 0th position. So that's the top 0 being over here. Then top 1 is the first position element, is like column. Then the current key. What is the current key with us? Okay, so this current key will be changing again and again. So initially it has the whole key, so that's the top of 2. Fine. Then what's the total like the distance we travel so far is like top of 3. Fine. Now what we're checking is like if row is m-1 and column is n-1. If we've reached that position, so that means this is the total distance. We're returning our distance. Done. Break the array, we return the distance. We don't need to do anything. Done with that thing. Now, if not, we need to traverse this 4 directions, right? We need to traverse these 4 directions. So what are you doing? It's a array from like I equal to 0 till I less than 4. So that's like all the 4 directions. So what you're doing over here is like simply see with row, like the new row, nr is new row. Okay, so with row we are just adding directions of I. Say I is 0. Okay, so with row we are adding 0, and with column there's a new column. With column we're adding directions of I plus 1. I plus 1 is 1. So first of all, what it happens, we changed it to the next column. Okay, next of all, what will happen, we'll change to the bottom, like row will increase but the column will remain same, right? So first of all, the first case we're checking for this. In the next case we're checking for this, like we're adding this to our row and column, so that means it will move bottom. Then we're checking for 0 minus 1. Okay, 0 minus 1 is like moving to the left, and then minus 1 0 is like moving to the top. It's moving to the top simply. Okay, so what we're doing is like we are running the loop for this all the 4 directions. Now we are checking if a new row is less than 0, or new row is m equals m, or new column is less than 0, or new column is equal to n. That means somehow we are moving out of our index, or somehow we are moving out of the boundaries of our grid. Okay, so we're just continuing with it, so there's no point with that. Further, we're checking if the new k equal to, we're taking another new k is equal to current k minus grid of new row new column. Now something over here you need to understand is like grid stores, like grid has two values. Each cell is either 0 empty or 1 obstacle. Fine, so there's either 0 or 1. Fine, so for the current k is like we are subtracting the whatever the new like the position grid value is there. So if there's a grid value as 1, then only the new k will change from the current k, right? If the grid value is 0 itself, then there's nothing to change, right? There's no change in it. Okay, so if there's no change in it, then go ahead with that. I mean, what's wrong? We have a grid value in itself, right? So there's no change in it. So depending on what the grid value is, it's like we're changing the value of k, right? So this is an important step. You may say that this is something we are adding new to our this approach, like when we are given additional k value, right? Further, further, what we're doing, if our new k is greater than equal to 0, that is k hasn't been exhausted. Okay, like there's still some k remaining, or k somehow is just reached 0. Okay, and we're checking that we have not visited this position, that is the new visited row column, and with the new k. Okay, so if we have not visited this position, then we will make this visited, because that's the new row new column we just end up having over here, right? That's the new row, and we added that new row new column to our queue. Fine, and we make a distance count plus 1, say. So over here, that's just a BFS approach, as I say again and again. So over here we are just like moving to 4 directions, and we're checking if our current the new positions, like the top, bottom, left and right, these new positions are not visited by us, then we are marking them to be visited true, and we are adding this to our queue. That means we are moving to that position. Fine, next hour we'll keep doing that. And ultimately, if we have not reached to this position, okay, if we have not reached the end of the whole grid, that is we don't return this distance, then we end up returning -1. So this is a pretty simple approach, the one we used as usual, just added with a additional variable to handle over here. Okay, so I hope it's easy to understand. Now let's quickly run this code, and here you will understand how this code works for us. Okay, so this is like a pretty fast solution. You can see it's like a 7ms solution. Obviously this varies sometimes, so it's pretty fast solution that you come across over here. Okay, so I hope I can make you understand how you can solve this question, and how you can make like understand this question. Also, comment down if you have any doubts related to this question. I'll be happy to help you out in the comments as well. So thank you all for watching this video. Hope to see you soon in my next video as well. Thank you.